Hi everyone, welcome to my YouTube channel, and in this video we will look at problem 322 from 328 from Leetcode. Okay, so here is the problem statement. Here is the constraint for this problem. Why don't you guys try this problem on your own? Like you don't have to get it right on your first try, but I think you guys should try this on your own before we look at my solution together. Anyway, so that's it, and let's see our solution. Let's see my solution together then. Okay, so here I will be using this example 1 2 3 4 5 6, and so that will be, well, so it's gonna be this example, but I have additional node here. So we have 1 3 5 and 2 4 6, and that's what we want. And yeah, so how should we do this in, so the problem asks us to do this in a what is it, O of n, and with time space complexity of constant space complexity, and we have a linear time complexity. All right, so constant time complexity means like you probably have like few variables, like not proportional to the length of this linked list, and then time complexity equal to linear. That means you'll be iterating once, so you do the linear scan once. So that's what we should be doing. And how should we do this? So for this kind of problem, I would do the I would create few variables, and like so the way I did this is you try with very small sample size. So initially I did like 1 2 and 3, and I tried to see how I can move this around, and so this is the way I did it. So we would create a few variables. Here we have a current, and this is just some dummy node, like list node, and then here we have a two additional nodes here with some like numbers -1 and -2. Like this value itself like doesn't matter, because when we return the result we will be skipping this, and we will just return out dot next, so whatever here that comes next. And this one, the node that comes after this will be this guy, so we will be returning out dot next. So this value doesn't matter, like whatever you put, you can put -100, you can put like 200, it doesn't matter. So that's what we have, and then we create another variable, and this is like a what is it, bookkeeping variable, like count. So my strategy will be starting with this. Well, if this is, well, this is the odd position, right? So we will be returning appending this to our this linked list, and then we will be incrementing this count variable by 1, and then when we are at here, well, we do the modulo like by 2, and then if it is equal to 0, then we append this to our even linked list. And so that's what's going on here. And here is the code for this problem. Basically I just have so odd equals list node and -1, that's this guy. Even equals list node -2, that's this guy. And odd underscore pointer will be pointing to this one, and even underscore pointer will be pointing to this one. And then we have a count variable equal to 1, and we have a current. Actually this one should be, yeah, so so this current equals list node of -3, that's this guy. And then now we have a while loop, and while head itself is not equal to like null or none, and we are here. Current equals head. What does that mean? So our current will be pointing to wherever head is pointing to, and that is here. So our current will be pointing to here. Next, we are at head equals head dot next. What does that mean? Well, head was initially here. Head dot next will be pointing to this guy, so head will be pointing to this guy, and that's what's going on here. And I basically moved this one to here because it may get confusing towards the end, but anyway, that's for this part. And then now we are at current dot next equals none. So here if you look at here, we had a like arrow from here to here. now we just sever that linked list, sever the link. So and then now we are at this if and else statement. Initially we have a count equals 1, so we are at here, we are in this else statement. And what do we do here? Out underscore pointer dot next, that will be so out underscore pointer dot next will be equal to current. What does that mean? So this guy dot next will be pointing to wherever current is pointing to. Current is pointing to this one, so out underscore pointer dot next will be this guy. This guy will be pointing to this one, so that's why we have an arrow here. And then we have a out underscore pointer equals out underscore pointer dot next. What does that mean? We basically move this pointer, which is pointing to this one, and then this one will be pointing to this one. So that's what's going on here. And then we increment our count variable by 1, so count becomes 2. And then we are back here. Current is now pointing to head. Before, current was pointing to here. Now current is pointing here, and then we will be moving our head to the head.next, and that's what's going on here. And then we sever this link, and then we will be creating a link from here to here, and that's done by this. And then we have even underscore pointer equals even underscore pointer dot next. We just basically move even pointer, which was pointing to here, and that's what's going on here. And then we increment our count variable by 1, so count is now 3. And so you repeat this again and again until head is pointing to none, right? So when we are at here, and our head will be moving to head.next will be some empty node. And so when we when we finish this constructing odd and even linked list, then our head is pointing to empty node, and then we will exit the while loop. And then when we exit the while loop, we have to create, like, link these two these two linked lists. And how do we do that? Well, out underscore pointer will be pointing to the last element, and so we basically want to link this one to this one. So we do that by out pointer dot next. So this one dot next will be pointing to wherever even dot next is pointing to. Even is pointing to here. Even dot next will be pointing to this guy. So that will create a link. So we have a arrow here. So I should, yeah. And then we return out.next. If we return out, then we will be including this one, and we do not want this. So we return out.next. So they will return this guy. And that is the code. That is the code for, the solution for this problem. Okay, so here is the code for that problem. Exactly the same code. And then so we do have to consider the edge case here. If you look at here, it says the number of nodes in the linked list, in the given linked list, can be from 0 to 10 to the power of 4. So in the case that when we are given an empty linked list, so this will take care of the case. So if not head, if the linked list is empty, then we just return itself. So that is for this problem. And yeah, let's run this. Okay, so yeah, so I tried this like 15 minutes ago, but yeah, sometimes I got like 80%, it beats 80%, sometimes I got 9%, but anyway, that is for this problem. Yeah, so basically like problems like this where you have to do some manipulation given for the given linked list, try to think about like creating some dummy list node, and then try to manipulate the pointers. Like this kind of problems, I don't think they're that difficult once you like see some tricks. And so yeah, so don't get discouraged, and if my video helps you guys understanding this problem, please give me thumbs up and subscribe to my channel. If you have questions, or if my explanation is not clear, then write a comment, and I'm more than happy to respond to your questions and feedback and comments. So yeah, anyway, that is for this. I hope you guys had a great evening, and I will see you guys next time. Bye bye.